All right. We're live for day 24 of Advent Code 2020, 2024. So, the Christmas Eve problem. 2 days left. Um, and for a warm up, I still enjoyed going back through these older problems that are referenced. So, what's this one? 2016, day 9. Maybe we'll take a look at that. We come across a data link port to a new part of the network. Um, Documentation for the format is nearby. Okay. Format compresses a sequence of characters, white space is ignored to indicate that some sequence should be repeated. Markers added to the file, and to decompress this, we take the next 10 characters and repeat them 2 times. Then continue the reading the file after the repeated data. Okay. Parentheses are just normal data. Okay, so let's look at an example, or the input at least. Those parentheses are probably going to mean something in part 2. Interesting. Okay, what's that marker? 10 by 2. Let's look for some examples of that marker. Okay, that means the next 10 characters we repeat twice. Hmm. I wonder what those others mean. Okay, so what's the question? What is the decompressed length of the file? Don't count white space. What white space is there? Is it just the new lines? So Advent contains no markers and decompresses to itself, yada yada. So the total length is just 6. I mean, so basically anytime there's a 10 by 2. Oh, wait. No, we care about all of these bits. And the marker itself is not included. So we remove that, take the next 10. So this, you take the next 3, repeat 3 times, and the markers could overlap, couldn't they? Could they? Parentheses or other characters appear within the data referenced by the marker. That's okay. So could it be the case that after a marker completes, we then have a new marker appear after? Right, this 171 by 15. So we take all of that, and then we recursively. Okay, yeah, that's a gnarly one. This might be a case for memo. Hey there, Hellhound. Welcome, welcome. This is a problem that was referenced from yesterday's. And basically, we want the length of all these after all these parentheses are handled. And they are handled by taking the next so many characters and repeating them. And I suspect that it's recursive, where sometimes the next so and so many characters includes a marker itself. So it matters the order that we do it. It has to be left to right. Let's see an example. So 6 by 1 simply becomes 1 by 3a. Wait, the 1 by 3 looks like a marker, but because it's within the data section of an arc. Oh, okay, so it's not recursive, at least for part 1. Okay. So, I mean, in a way, that also makes it less simple because then I have to realize that this is not a marker. Okay, so we just take the next 6 and then we can just keep iterating on this thing. Easy enough, at least for part 1. Um, Give me 1 sec. Uh, oh, and I should set an alarm. What do we have? 12 minutes? I'll set a 10-minute timer. Okay, let's open up yesterday's problem. It is almost finale. So close. Are you bracing for a tough one? I was thinking about the past year problems, and day 24 was never, say, the hardest in any of them, but it was always, it was always something. So let's see. 23, 2, 1. I guess I've got 2020. So last year, oh, it was the intersection of the 3 points, which wasn't that hard in practice, but it did take me a while to do the Gaussian elimination. Icy Black Deep helped me a lot with that one. The Blizzard Basin from 2022. So this was just a search with time added to the state. So it was like a 3D Dijkstra. That wasn't bad. Day 24, 2023, 2. Yeah, so there's a state for the blizzards, calculating where the blizzards are at any given time. And then our state, this looks like a normal Dijkstra, and it's just at the start. The state includes time, really. Nothing here looks different from my usual Dijkstra. Yeah. And then 2021, what did we have? Okay. This was a decompiling problem. We had to figure out, we had to figure out what this little program was doing. So this is a lot like day 17 of this year. Okay, this one Took me a long time. It took me all day. Well, not all day, but I had to get back to it the next night. And 2020, if I've done this, I don't think I've done this. Some hex map thing. Okay. So it could be a challenge, but won't be the hardest of the season. 2 more days. Yeah, I'll miss this too. But I think this year I'll continue streaming afterwards. Not every night, maybe like once a week. I know after day 25 every year, midnight comes along. I'm like, what do I do? What do I do now? It's been my routine for the whole last month. Mm. All right. I mean, I was thinking about working on this problem. I might not actually get to it. I don't start early enough for warm-ups these days. Uh, okay, I'm just creating a new file here for that 2016 problem. Because I don't think I've done any 2016 problems yet. I hear that based on the stats, 2016 was a harder year, or probably the hardest year, or it's at least a year in which the leaderboards struggled the most. Okay, let's see if we can get 2016 day. What is this, 9? Okay, so I guess we have a length method. That's all we really want. So we're gonna just make this make string. I think we have just one line in our input. And length, well, length 1 already. So we're gonna give just make it a long. Well, let's check. So input dot size. I don't think it'll actually get all that big. We can be an int. I'm excited for this night. This should be the last tricky one, like the last real one. Tomorrow is always a break night, right? Um, what would we do here? We would take until the next marker. So we're gonna take line dot span. Yeah. And the character is not equal to, I guess, an opening parenthesis. So val pre and then the rest. So we do pre dot length plus well, I mean, let's take the rest already. Let's handle that. Or no, let's handle that recursively. So if line dot starts with um, parenthesis. Then something else we do this thing recurse. So pre.length plus length one of the rest. It's always a half day. Yes, right. Always a half day and never too hard of a problem. Michael, you're going to take 3, 4 days off after. Makes sense. I'll probably take a couple of weeks off. But you've streamed every day since the second. Nice. Yeah, I feel like a lot of people dropped off this year. Okay, we've got 3 minutes left. I'm not going to get through this. But we could at least do a little bit parse the marker. No, we're going to do it this way. So next parens, and then let's call this L times L times N. And then we have the rest following the parenthesis. How many stars do I have? I have all of them. So yeah, I've done 2 each day. I'm not missing any. Part 2 for 13, 16, and 17. Hey, good morning. Good morning. Merry Christmas or Merry Christmas Eve. Okay, I should get today's problem set up. Today's a complete cold start. Just woke up. No coffee? All right. Yes. Good luck, everyone. Day 24. I feel calm. I feel like I should feel more amped up and ready, but I just feel calm. I feel rested this time. So we'll see how I do. Hmm. Uh, All right, here we are. Good luck. Unit historians arrive at the edge of the largest grove, somewhere in the jungle. Elves installed a device that monitors fruit. It's malfunctioning. Okay. Boolean logic gates. Evaluate true or false. And gate, yada yada, or XOR. Pretty Stanford. Let's take a look at the input. I don't think I pulled it yet. Okay. So, what is this? Interesting. So it starts with a bunch of registers. I'm not sure I understand what all those operations are. Okay, you can read about it a bit more. Gates wait until both inputs are received before producing output. So a wire can carry no value at all. There are no loops, good to hear. The output will not change until the whole system is reset. Okay, so a pretty simple version of a circuit. Each wire connects to at most one output, but can be reconnected to many inputs. Okay, wire, one output, but many inputs. You write down all the gate connections and initial wire values. Okay. Let's take a look at that in here. Let's do it this way. So all the initial wire values, and this is, wait, I am still not sure I understand the input. So here's an example. Combining bits of all numbers to produce a value on all wires starting with Z. Z00 is the least significant bit. Okay. We write down all the gate connections and initial wire values. So these are wire values, right? X00. And gates wait for inputs. Some wires need to start with a value. And these are gates. I wonder if it's worth saying whether or not a wire has a value. If we can just get it eventually. If we just work through it backwards. So it has an output here. I think we can just evaluate from the end, from all the Z values. And I guess, so these are only the wires that have a value, right? And there can be other wires that exist, but aren't specified. So if we go back recursively, some might be not set yet. Okay, so val initial wires. And we gotta take input.collect. And let's see. It's always gonna have a name, colon, and then a 1 or a 0. I think I'll just parse the 1 and 0 in separate cases. So this will do a named true, and the 0 will do named false. Yeah, and then the initial gates. So again, we'll collect on the input and match things that look like gates. I think I'll parse these into a structure. So we'll have like an in gate. So case XOR And we'll make this like an infix case. No, can we do that? Case class. Okay, we can make it infix case class. So that has an A, I guess it's the name of the input, and then B string. Okay, I'm gonna model these as a sealed trait. Um, Gate. So we have and or an XOR. And I suppose we'll put an eval there at some point. But it'll need some sort of context of wire values. All right, so we have we'll call it W1, wire one, and then and wire two. I don't like typing the numbers, we'll just do A and B. A and B. Let's just do Copilot on here for this boilerplate. Okay. And let's extract the gates that give us the Z values. Oh, wait. These gates have an output gate as well. And each gate would have a unique output, right? So how do we do this? We'll parse the arrow and then we'll just call it out. And then we'll tuple it. I think we'll tuple it. Oh, and the reason I made the case classes infix is so I can do this, A and B. It's silly, but we're allowed to do it. Or I guess not. Let's not be silly. Oh, right. These were all undercased. There we go. So val Z gates. So this can be a list of gate from high to low, right? Z00 is a least significant bit. Okay. So we're gonna take netgates.filter. So out. If out starts with Z. Yeah. Now let's do this. Okay, out starts with Z. And then we're gonna map that. I guess we can turn this into collect. So this arrow here turns into an if guard. And just take the gate and the number of the out. So val, let's parse it this way. Z and then index. Just do ID equals out. So we have gate to id.toInt. Actually, we don't even need to toInt that. Or we could do just gate to out.tail. Okay, that works. And we're going to sort that by out and keep the 1. That will naturally sort it least significant bit to greatest. I don't think we should do any mapping, actually. We should keep the names. Okay. And to evaluate, I still haven't answered the question of whether we do this bottom up or top down. So if we do it top down, we look at all these z values, and then I guess we look into a map of wire values. And if the value doesn't exist, then we then look for that things. Yeah, we look in there to evaluate it. Okay, so we can do that. This init wires, I'm going to turn this into a map. So map.from, and it is a string to Boolean. And we evaluate over several steps. So we have like we have a context that we pass along as we do this. You got part 1, but now you need your coffee. All right, you earned it. Yeah, I'm gonna do this top down. What order do I have these in? I want to reverse that. Let's sort by, no, there's no negative there. We'll just reverse it. And I think we actually want out to come first. So out.tail to gate. So we're going to take z gates and we're going to fold left into a new list of values. Yeah, we're going to fold left into an int. So we're just going to start with a 0 and just add bits into here. Okay, so we have, oh, I do think we also need like a wire state dictionary, but we'll get there. Yeah, I think we'll probably need that. So we have the value, and then we have some gate and some output. And we're going to evaluate that gate using a map, and when we evaluate, we return a new map. So def eval gate. And we have a, yeah, we have bunch of wire values. And then we're going to return the Boolean and then the new state. Let's just give that map a name. So we'll call it our state. Map from string to Boolean. Okay. So we mentioned the gate, make that exhaustive. And we recursively evaluate the A and the B. So to be able to quickly get what gate we're evaluating based on what that wire is connected to. So so we have like the A value. So that's a wire. I guess we have like an eval function for wires as well. So let's do that. Def eval wire string, and we still have the same state. And then I suppose we'll return that wire's value. Okay. So I'm gonna turn Copilot off here. Get or else. So our new value, we'll call it V. V equals wires.get or else. We do something. I should just use a mutable map. That'd be easier, but I'm committed here. I'm going to do this in a non-mutable style. Let's do it this way. If wires contains value for that wire, then wires wire. Otherwise, you evaluate recursively. So we have init gates. A gate might not be on this map yet. No, it should be in there. I think I do want this to be a map from gate to their outputs. So we'll do map on this gate string. Part 2 is confusing, huh? Good. I'd like a confusing problem tonight. So to evaluate a wire, we look at init gates. Oh wait, this is a map from gate to string. I guess we want to index into that by the name of its output, don't we? So let's change that up. Only one person has solved part 2 yet? Oh my god, we're 20 minutes in. Ooh, okay, we're in for a night. And Hellhound's still on part 1. Wow, Blue, you're fast tonight. Okay, so I guess it's a map from a string to gate instead. String to gate. I guess we have to order these out. Gate. Okay. I'll do an iterator. No, it's a list. Okay. We'll call this state. Okay. If state contains wire, then state, not wire. Okay. So we take our, if it's not found, we look at our initial gates. And then I guess we have to evaluate that. So init gates based on that wire. And then we evaluate that. So evaluate that, and we pass along the state. So val s, and then new state, no, value in the state is the result of doing that evaluation. And I guess that is what we return. So, I mean, that's that. Let's format that way. Okay, so now we can do this by recursing. So A and B here are other wire states, so we can do an eval. So eval yeah, eval A. We're going to introduce piping here. This is something I could do similar to my day. Which day did we have the computer? Day 17, where I managed to state that way. But I'm not doing it quite that way. It's the way I probably should do this if I were trying to make it nice. Oh, state wire. State wire gives us a value, and then we need to cons that on to just the same state. The state hasn't been updated. Okay. So eval a dot pipe. So when we pipe, what do we have? We have a case, a new state. So we have a value and a state. So we eval a value and state. And we use that value and state to do another eval. So eval b. What are we going to call this? We'll call it VA, value of A. And we validate B. I'm going to write this as state so that I shadow the outer state and don't accidentally do that. Validate B with our state. I feel like I should just use the state as like an implicit context. That's a good tool Scala gives us here. So VB and state. And now at this point, that is simply what we return. Right? Because when we eval, the state is already updated. Oh, wait, you still need to evaluate the actual gate. Yes, I guess we just do A and B. So VA and VB, and we pair that with the state. Eval A with our state pipe. This works. I should do it. I should make these return options, and I could do this as a for comprehension. And I think I would like how that turns out, as opposed to this nested pipe and match. But that's a refactor we can do later. And I'm just gonna copy paste this twice and change the and to or. You think part two is confusing on purpose? Well, Eric says he writes problems without keeping LLMs in mind. I'm sure it probably feels that way. Does that work properly on Booleans? Okay, yeah. Okay, I think this gives me part one. So we're gonna take our Z gates and fold left with an eval here. So we have our initial state, which will be what? Init wires. Yeah, let's say this is the state. So init wires. So we now have a value that we're building up, and then we have a state that we're passing on. Yeah, it does feel pretty straightforward. I'm taking my time. I mean, when I'm taking time like this, I should at least be making it nice. I guess I wouldn't call this nice. There's a much nicer way to write this I'd like to show you all later. Okay, value state gate out. And we just do kind of the same thing. So we evaluate the gate. Given our state, and then get a value from there. So we have a value and a new state. And then we need to give a new value and a new state. So we're just going to do, let me think. We take the value and I suppose we're just going to add it, like bitwise and it. No, bitwise or it. So value bitwise or with the V. Does that work with a Boolean? Not sure if that works with a Boolean, but we can figure that out. And then we pair that with the new state that we received. Oh yeah, we're folding left into state. Okay, we can't bitwise or that. So if V then 1 else 0. Sure. We have some sort of syntax error going on here. Um, I'm so close. I'll be right with all of you. I'm not sure what's going on here with my syntax error. Outdent expected. I know, let's put that in a paren. That's probably it. Okay. Oh, but we are starting. Are we starting? I don't know what order we're doing this in. That better be the highest bit first. I'm expecting that to be the highest bit first. No implicit ordering by gate, right? We want by the string. And we want, do we want C gates? Where do we use this? A gate and an output. Here we're doing an out and then a gate. I don't know why we want to change that order. Okay, yeah, I guess we're doing string to gate. So we sort by the string, then reverse it. So state here, right, we're just gonna call this S for the new state. Key not found 45. I'm treating something opposite here. What is gate? What's a type of gate? Gate is a string. Yeah, we've mixed them up now. So we have wire, out wire, and then we have the gate. And just to check this, so our Z gates are sorted in order from the highest to the lowest. Oh, and that's going to be a long 45 bits. Okay, I think I've got my part one answer. No. We OR it with 1. So if we OR it with 1, oh wait, we forgot the shift. So we OR it with 1. I think we shift the value first. So the value that we already have, we shift to the left by 1. And then we OR. There we go. So we're going to copy that worksheet output. Okay, I'm caught up in part 1. Now I get to see what y'all are talking about. Username is really hard. You've been trying 5 times and failed first. I got it on my first try. I don't think this is hard. I just took my time writing it. Nothing successful until now. Maybe it's a day 17 part 2 kind of a thing. Reverse engineering, huh? Cool. We're in for no problem then. Let me see what y'all are reading. So after inspecting the monitoring device more closely, you determined that the system you're simulating is trying to add 2 binary numbers. This is supposed to be an adder. Ooh. It is treating bits and wires starting with X as one binary number, treating bits and wires starting with Y as a second binary number. Wait, can we see our input? Oh, they only gave us, yeah, they only gave us X's and Y's to start. I didn't notice that. All the other wires are just that. Okay, so we have to fix the machine. Ooh, is this a day for using GraphViz? As a second number, then attempting to add those two numbers together. The output of this operation is produced as a binary number on the wire starting with Z. Okay. The initial value for the wires in your puzzle represent just one instance of a pair of numbers that sum to the wrong value. Ultimately, any two binary numbers provided as input should be handled correctly. That is, for any combination of bits and wires starting with X and wires starting with Y. Okay. Some of the two numbers those bits represent should be produced as a binary number. Okay. For example, if you have an addition system with 4 X wires, 4 Y wires. Yeah. Any 4-bit number on the Y number, and eventually find the sum of those two numbers as a 5-bit number on the Z wires. One of the many ways you can provide numbers to such a system would be to pass 11 on the X wires and 13 on the Y wires. Sure. If the system were working correctly, then after everything finished processing, you'd find 24. Your actual system needs to add numbers with many more bits and therefore has many more wires. Based on forensic analysis, you can tell there are exactly 4 pairs of gates whose output wires have been swapped. Okay. How many gates are there? So init gates, that size. There are 222. 4 pairs that have been swapped. That is, if we were to brute force that, that is a 222 choices for like a first wire, times 223 for a second wire. Basically, okay, we choose 8 gates that are involved by doing 222 factorial over 216 factorial, and then divide by, divide by 216 factorial. And divide also by 4 factorial, because there are 4 choices, like we can just swap the order of the 4 gates that are having their pairs swapped. And for each of those, there are 2 orders to write that, so divide by 2 times 4. So what is that value? 222 times 22 times 220 times 219, and we take that all the way to 216. 1, 2, 3, 4, 5, 6, 7. And this could be manageable. Let's 4 factorial, divide by 24, and then divide by 8. So this is how many we'd have to try if you're brute forcing. That's 5 million. So yeah, we're not brute forcing that. But we could check like sub circuits. So we can check one bit column at a time, basically. Uh, yeah, we could test with 1, 1, and that should do 2, 2. That shouldn't touch anything else. Yeah, we test a position. So we can add in just a state. Let's call this add. Def add. So given an x and a y, x int, no, it's gonna be a long, x long, y long. Brute force is what crashed your Mac. Yeah, no, I definitely believe you. I believe you that brute force is not an option. I believe it just from reading the problem, but a part of me wanted to get what the actual number is. And yeah, so now we know there are 5 million to check. So I'm not going to crash my stream. And then we get along. And then I'm going to make a version of this that's just for a position. Hmm. So how do we do this? We have a set of gates. We'll pass in the set of gates as a parameter because we want to switch things there, right? So z, no, we have gates, which is going to be, how are we doing this? A map from string to gate. Okay. And the initial state, in this case, is determined by our x and y. Yeah, val init x. So for each bit, you don't know how long x and y are going to be. So we're gonna iterate. It's going to be, let's just do an unfold. Iterator dot unfold, starting with x. And we're going to output. So we're going from a long, and no, what we want to output here is a list string to Boolean. Yeah, and then given our state in this case is a long. Oh, you put the type here in the wrong place. But we don't need it. So if it's 0, well, I don't know. We'll have some number n, and if n, well, let's say option dot when n is not equal to 0, then we have more state to output. So the bit is just going to be n with n with what? We're just going to AND that with 1. Nope, nope, we want to AND it. AND it with 1. And yeah, that's what we'll output. We'll output that, and then we're going to shift to the right. Oh no, we need a name. So I guess we also have a name as part of our state. So we have the value, and then we have the counter 0. And long, and then I for the place. I mean, I suppose we could always just zip with index afterwards. Yeah, I don't want to do this in here. We don't need to be adding things manually. Okay, so we take our n and then we shift it. So we're taking from the least bit first, so we're going to shift it to the right by 1. We'll call this the bits. Val bits. And we're going to do bits dot zip with index. So we had the ones first, and we're going to map. So case the bit and the I is going to be a string and a Boolean. So a string composed from here. So it's going to be 0d2 %0d2. Okay, so something like this. So f do our thing %0d2. Okay, in this case, our thing is just I, the index. And there's a leading x there. X in a 2-digit name. And the value. So if b equals fb, well, we just do b equals 1. So b equals 1. And then that to map. Okay, great. I'm just gonna make this a function. Def int state. So given a prefix, so a prefix character or name or whatever, so that's a string, and given some value n, which is a long, then what we want is a map from a string to Boolean. This might be another time box game over. 35 people solved. I could make top 100. I think I do have a good strategy. Right? Let me think. My strategy here is to take each place and then see if that can add, that column properly. And then I will find all the places where, yeah, I'll find all the columns that are wrong. And then within those columns, I could just then brute search within there, right? Swap the values of those columns until I find something that works. Yeah, so I think I have a strategy, and I think it's solid. I don't know why that would be. I mean, unless the map here, the graph of gates was so just weirdly interconnected. that I don't know, many more columns were wrong than just what was there. So if that's the case, then we're in for a little bit of a longer night because I need to think of a different strategy. But if this graph is really just a binary adder, right? If this is just an adder with some wires swapped, then we're totally fine. I think we can fix an adder. In fact, I think that's one way to solve this problem, right? Just do a graph viz and then look at it. Like we know what a binary adder is supposed to look like. Let me pull that up. Binary adder circuit. I guess we have to also do like a half adder. Okay, yeah. So like this is a 1-bit adder. Everything's wired in that way. I do have to consider, let's say something is used. Nothing goes to like too many outputs to make this difficult, right? Let's look at a half adder. Half adder. Oh, adder circuit. And we can do some exploration and check if there are any gates that are connected to a wildly high number of other gates. That's the only thing that really throw in a wrench. Okay, I like this diagram. So this is a half adder. So we basically just have a bunch of half adders wired together in sequence. And nothing is connected to more than 2 outputs. So we can check all the outputs and check how many they are connected to. And that will tell me right now whether or not my strategy will work. So I think I will do that check, but first I have to finish doing this add implementation. Let's do this. Okay, so just copy pasting this over so I could get my state from an integer that I'm testing. Unfold from n. Sure, we will shadow this. Bit zip with index and map. Start with a name. And we'll test that out. I'm just going to comment out my part 1. So in state, let's say 5. So let's say the name is x, the value is 5. Oh, this is a prefix. Okay. Missing format with exception. Like %0. Oh, 02D. There we go. And then for each print line, x00 is true, x01 is false, x02 is true. That looks like a 5 to me. Let's do a 10 just to make sure that we have the order right. False, true, false, true. Okay, this looks good to me. So init x is going to be int state with a prefix x, and we just pass along x. And same thing for y. And then we're just going to sum those. And we basically use it in this thing. So we should give this thing a name. So basically init wires here needs to become a variable. Should C gates be a parameter that we pass in? No, I don't think those outputs are gonna be swapped out of order. That'd be silly. Right? There's no way they're swapping us there. I hope not. I don't think so. Well, val init wires is going to be just init x plus plus init y. And yeah, we do that with some set of gates we pass in. Found a unit required along somewhere. Oh, right. Return ends 1. So z value. And then this is like the final state, which we're ignoring. Z value. So let's add, let's add 1 and 1 with our init gates. Key not found x44. Oh, we need yeah, we need a default value there. Oh, that's gonna mess with things because we don't want all the other wires defaulting to 0. Let's just do, I don't know, in our int state, let's pad it with zeros. Yeah. And I just want to test something when we add maps. So let's say we have a map that sets 1 to, I don't know, 1. And let's say we add another map that sets 1 to 2. Then that will overwrite it, right? Okay. So we can just start by adding some padding. Now, padding equals, this is at most n long, so we're just going to do 64. 0 until 64 dot map with this name here. So I to the name, which is coupled with a false. And this, we'll call this the binary map. So val binary, and we'll do padding plus binary. Okay, so that should make it 0 to start. Now this should run. Also, why did it care about gate 44? Because, I guess because we're evaluating that gate. Wait, padding needs to be a map. Okay. Hey, look, we can add 1 and 1. Let's see which columns. Let's take a look at our init gates. So init gates, this is a mapping from a string to a gate. This is the output of a gate. So let's look at gates. I think for each input, we want to see how many share that. Yeah, okay. How would we do this? So we're going to do init.flat map. And this is string to gates, right? So init gates. Okay, so given a name, an output name, and then we have a gate which is going to have an A and B value. Let's see, def A string, def B string. Okay, our gate has an A and a B value. So we want to know every so this gate has inputs. We want to know what those inputs are connected to. So we're going to do A to this gate, I suppose. Or we could map it directly to the output. So we have a list of A to this output and B to this output. The outputs are one-to-one with gates. And then we're going to do a group map. So we're going to group by the input name and just keep those values. And then we actually want to group map reduce just to get the count. Okay. I mean, this is just confirming my guess. Oh, wait, gate.a, gate.b, but I'm hoping none of these are crazy. Let's do a sort to list dot sort by the ladder. Is not a member a string? Oh, sorry, we want counts of these. Yeah, okay, let's just do a group map. So we get a list of gates it's connected to. Let's start with that. For each print line. So for every input, what are the gates it's connected to? Look at that, no more than 2 gates ever. So I think my strategy will work because this bar graph is probably just an adder. Okay, I won't be on the leaderboard, but I can do this. So for I don't know, 0 until 64. We're gonna try just adding 1 on each of these. So we're gonna map I don't know, an I index, and we're gonna add. So we're gonna take add 1, 1, where each of those are shifted I times to the left. Shift left I. Shift left I. So we want a set of gates such that these are all gates. All 2. And it could be like just the carry is wrong, right? So like these might still work even though they are wrong in some other way. Oh, are these new toys? Is this like a new Christmas or do they already exist? I appreciate the lurk and listen. Let's add 2 and 2 with our normal init gates. Yeah, we get 4 there. And let's do all these additions. Um, that is taking a hot minute. Maybe I should set myself up for a faster simulation. Why is that taking so long? Like, it didn't take that long to calculate any, these two. And I'm just doing it 64 times. It took 3 seconds to do. Okay. Okay, well, we can't do that all at once. Let's just do 0 until 8. The first 8 bits. They are your old toys from 30 years ago. Oh, that's nice. Okay, surely you can handle adding 4 times. The problem is my add looks at all the values of z, and we don't care about all the values of all the z gates. So I should possibly also pass in the z gates I want to evaluate, because we don't want to simulate the entire circuit when we only care about a column. And I'm still thinking about making my implementation nicer. Evaluate a particular gate given a state. Yeah, okay, instead of doing the full add, I suppose we could pass in that state the x and the y state. So we can write an add column version and look at the values that adds to. Okay, but here we have this. Oh wait, what's that? Did this run? Did it cease to run? Okay. Well, I can't even run the full simulation 8 times. Ah, well, Blue must have quality toys from his youth then. Okay, I'm gonna make an add call version. Add bit. So def add bit. We only evaluate at a certain place, so we'll still use add instead of taking. We're gonna take a list of z gates. So let's pass in. Let's pass in places. Yeah, or we'll just call it column, and that's going to be an int. And we want that column and the next column. So val z gates equals. What was z gates originally here? Val z gates. To list a string to gate. Okay. So add bit. We have a list, and we have z percent. Oh, we have a dollar and percent 0d, 02d. Um, just make this a set on which we filter the keys of the Z gates. I don't know, new Z gates. Patrick Salmon, welcome. What am I working on? Well, this is Advent of Code, the penultimate day. It is it is an advent calendar where every night comes out 2 new programming puzzles. So I'm currently on part 2 of tonight's programming puzzle. Okay, so here's our filter. Well, F, we'll just call it F. And then we have our column. And then we have our column plus 1. Right. And we're gonna take zgates.filter view dot. No, we're just gonna filter. So filter equal I don't know, f dot contains. What are our zgates? It's a name. It's an output name and a gate. So f dot contains the output name. Yeah. So we're gonna pass that in here. Use z gates. Okay, now we can just add a bit. So we can add a bit for column 0. Okay, and we could add 1 and 1 for any other column. Or I don't know, let's add 10 and, well, let's add 16 and 16. And this should be 0 because it's only adding the ones column, right? You feel like we're supposed to do this by manually inspecting the data? I feel like that is a valid solution here. Yeah, like part 17. In fact, I've been tempted to do that. I've been thinking of doing a graph viz. Well, the only reason I hesitate is I haven't generated graph viz in a while. I forget what website I even like to use for that. It doesn't feel as like handy. It's not like in my back pocket ready to pull out. I'd have to check the drawers, you know. Oh yes, part 2 of day 25 is always a freebie. We don't need that check anymore. But why is this not running? Oh, it's because VS Code hit the shitter. Okay. Okay, we'll give that a second to wake up. And maybe I have a graph viz somewhere online. Dreampath. Get IO. The thing is, how many nodes are there? Hmm. It's not going to be pretty. It's not going to be pretty at all, especially because part of the problem is going to be some wires that are going to be crossing like across the map or whatever. And if you have, I guess, 4 wires crossed, it's not going to be able to sort the image nicely. because those wires are going to confuse it. So I don't know. I think GraphViz might end up being a lot of work. Is this the GraphViz version I like? GraphViz. I know there's another one. Okay, so we'll consider doing that, but not right now. Okay, let's run this. Um, okay, well, I mean, I hope that's faster. Wait, adding 1 on 1 on the 0 gets us. Okay, yeah, sure, the 0 bit is going to be there, but should also be looking at the. Are my new Z gates in the wrong order? No, we're just doing a filter on the old Z gates, so they should still be in the same order. Um, but yeah, this is wrong now. We're just gonna print that out. New Z gates. Okay, so when you run this, oh, we got an empty list. Um, out. This is the output name. Z whatever. Let's print out whatever the set is to. Print line F. So those are the names that we're looking for. Oh, right. I had an S. We need to have an F. Whoops. An F interpolator here to format it. Okay, let's try that again. Okay, well now we get the correct set. We are looking for Z00 and Z01. And what are we filtering on? And if gates, our initial gates don't include Z gates, so we're just making up our gates, right? Hold on, Z. Right, they have gates that lead there. Yeah, Z gates is just a filter on that. In fact, this doesn't need to be a. Well, okay, I guess it is a collect because of. Oh, Z gates here. Right, it's a string of. It's a list of numbers. Number strings, even worse. Okay, let's look at where it's used. Z gates. I don't think I want to do that. Here, Z values, Z gates at fold left. Um, and each of those has a. Wait, there's an out and a gate. The out number. We're not using that out. Yeah, we're only using that out to sort them. Okay. Now Z gates. We just want this to be a filter. And sorting by one should still work. And it becomes high to low. Okay, now when we do this, this should work properly because we have the leading z that we're expecting. As soon as that runs. I know. Oh, right, we got an output of 2. Hey, great. So 1 and 1 adds to 2. Cool, and that ran fast enough for me. So let's run this add bit on a bunch of different bits. For, I don't know, column I from 0 until 64. We're just going to yield add bit for that column. So 1 shifted left I times, 1 shifted left I times, and then we're going to pass I here for those negates. Okay, so this should be, these should all be 2. And we can move our print lines. It's still taking a second to do that, and I'm not sure if this will handle things in that far down. No. Okay, let's just do 0 until 8. Wow. Okay, I just need to make my implementation more efficient if I'm going to test things this way. Okay, but look. We found some columns that are wrong already. So 0, 1, 2, 3, 4, 5. Columns 6 and 7 are wrong. It's 1, 2, 3, 4, 5, 6, 7. Okay. I want to test. Let's say we're just adding 1 and 0. Okay, let's make notes. 6. I know. Adds plus 1 equals what? Equals 0. 7 adds 1 plus 1 equals 1. And those two might be related. Right, the fact that one carries over into the other might be causing this to happen. So it could be that the 6 is wrong, and that causes the 7 to be wrong. Let's look at 8 until 16. Yeah, we haven't heard from Hellhound in a second. Oh man. Each run takes too long. Okay, so we have another wrong column. So 5, 6, 7, 8, 9. Wait, no. This is 8, 9, 10, 11, 12. So 12 adds 1 and 1 to 0. You're really tired. Oh, I feel for you there. I'm not so tired today. Today I'm a bit better off. Okay, so let's do 16 until 24. This is a slow process, but it gives us things to inspect, and I might end up doing a little bit of this manually, right? Like I had in mind, let's find all the columns that are wrong, and then we could look at all the gates related to adding those columns and do swaps around. But then I'm realizing now that There are a few gates. Let's see. Right. So for each column that's wrong, there are 5 gates to check. So we can't, I don't want to just swap wires between those 5 gates and the 5 gates of every other column that might be wrong. Right, for one, we could check that whatever gate we determine to be the sum, I think the sum gate should be the bit, right? The sum gate, like all the Z gates should be connected to not and, to NAND gates. I mean, unless like you can do this in the inverse, right? This could have been a you could do a NAND. You could have done an OR with everything else sort of flipped, De Morgan style. Um, so I'm probably gonna do this via a little bit of reverse engineering investigation because I don't want to just swap willy nilly, especially how slow it is just to inspect 8 columns. Okay, so this is 16 through 24. Did it run? Oh, it did not run. Interesting. 16 through 24 did not run in time. I mean, at this point, I think I'll do 0 until 64. Yeah, I'll do 0 until 64 or 16 until what's your max Z? 45? Z 45. Yeah, there's no 46. I wonder why 45 was chosen. Was this so that like people using JavaScript would be fine? um, that would have been nasty to make it 64 on them. 3 hours. Wait, what about 3 hours? Yeah, I think I just convinced myself as well that's not solvable in a decent time. Tyler Malone. Yeah, I think this will take reverse engineering. Um, let's do this. 16 until let's say 16 to 45. I'm just gonna try adding ones on those. Oh, I mean, I guess I could just add well, I do want to do the each bit manually, each bit individually. I was gonna say I could just add 1 1 1 1 1 to 1 1 1 1 1 to figure out like which one is wrong because it should just be 0 across the board. But I guess so. Given this I, we're gonna add bits, and I think we want to zip that with the index as well. And since this will run slowly in my worksheet, this I want to run in the terminal. Takes 3 hours to brute force a BFS. Yeah, I'm guessing he probably has it running in the terminal. Oh, also that. Oh, that's serious brute force. That's like literally every wire swapping around. Um, is it really 13 million pairings? Because I calculated 5 million. I mean, I guess 5 million for like the full set of swaps, subtracting out duplicates. So let's run this in a terminal that doesn't have a time limit. And that will probably take a couple minutes to run. But a couple of minutes is manageable and it'll give us good insight. Okay. Um, eval type is not a member. Oh, right. Uh, hmm. L4 DYV4MP. Quite a username. Thanks for the follow. Okay. Let's get this. Wait, so this add bit showing up here. That's weird. Um, waiting for that console to come up. I don't know what the deal is. What do we mean illegal start of a simple expression? 16 to 45, sure. And then we can map on that. I don't know. Oh man, do I have something running in the background? No. Oh wait, what is the key for checking? All right, we're just gonna kill SBT, SBTN, shut down. And we're gonna start a new instance. May you ask a spoilery question? Sure. Who do you think it'll be a spoiler from me? Oh wait, who's going? Oh, are you going out already, Blue? Ah, yeah, it is past an hour. Thanks for stopping by. Have a good one. Tomorrow, last day. Originally, it's 536 times to the eighth. Yeah. Okay, that's the figure I got. And then you can reduce it down to 20 wires. Yeah. Still in one? No, I finished one. I'm just doing some exploration. Oh, what's going on here? Okay, I'm just gonna kill all Java. And gonna start a new build server. I think most people here have finished with one already, and we're all just puzzling over part two together. And I know a few bits that are wrong, and I'm just I'm gonna inspect manually. Like I wanna know what the half adders in this graph in particular look like, right? Whether they're NAND based on the output or somehow flipped or something. And then I'll just check each of them kind of one by one in the graph. I want to check that all the Z outputs are connected to NAND gates. Geez, it's taking a second to compile. Something is really taking my system resources. Is it? Okay. Now let's copy paste all of this in. Okay, so that should have no time limit. And let's look at arrows to Z. XOR, XOR, XOR. Okay, so it seems like, okay, and there's one that's an AND, 13. So that is wrong. That AND gate shouldn't be outputting to Z13. But for the most part, they are XORs. Ooh, that's nasty. That yeah, even the output gates might have wires swapped. Um, okay, so all the Z gates are XORs except for Z45, which is an OR, and Z13. No, Z18 is an AND. I'm gonna take notes here. So Z45 is an OR. Oh, and what if they swapped like 2 bits, like 2 output gates? Like they're both still XORs. That'd be nasty. Yeah, there are a lot of nasty ways to mess with this. So Z45 is an OR. What was the one that we found as an AND? Um, Hold up. Well, we'll keep going forward. Okay. Z18 is an AND. Z18 is an AND. Okay. And then where is the last one? I should just be filtering. I should just be doing this in the console and worksheet. I can do it much faster. Z7 is an OR. Okay. Z07 is an OR. Okay. So something that should be an output or an XOR. So let's look at something that's correct and see what it's connected to. Let's say Z01. So Z01, GHH, GNN. And we could in turn look at each of those. I want to start doing this in a worksheet rather than just visually inspecting it. So init gates Z01. Oh, is there a Z00? Yeah, there's a 00 as well. But I guess this is what we're choosing to check. Oh, okay, and this thing. This thing is stuck in garbage collection. Which is interesting because I'm able to add 2 numbers. But when I do each column one at a time, it becomes much slower. I should just add 0 and 0, see what messes up, and then I should add like 1 1 1 1 1. Yeah, okay, we'll leave that running in the background because I'm fine with it. Like I should still have free memory because SPT is limited to 2 gigs by default. Yeah. Um, timeout reached. Oh, right. Yeah, 1645. You don't want that running. Okay, so let's do input.filter. What does our input look like? So we'll filter dot contains substring. Where's my autocomplete? I might have killed the worksheet. Okay. We'll draw out one of these circuits. So we'll start with that Z01. Where do we want to draw it? Right in here. And yeah, let's look back at this output. So the twos bit. Z let's use white. So Z01. This is an XOR gate. And actually, let's look for an adder that uses XOR. Sum. Oh wait, all of these use an XOR for the sum. I don't know why I thought it was a NAND. Okay, so pretty standard. Um, yeah. Can I draw? And what is it connected to? So there should be an A and a B. It would be whatever the A is. Well, actually, both of them should also be connected to an AND gate. So both of its inputs should be connected to an AND gate. So GHH and GNN. So GHH, GNN are both in fact connected here. And let's look at the arrow. Let's see if AND exists. GHH and GNN, QHQ. Great. So this goes to an AND. Oh, that's way too big. And QHQ. So I can search all of those programmatically. If we know it's always supposed to go to an AND. And each of those are supposed to come from what exactly? A and B. I think those should come from the X and the Y, right? They're just particular columns or bits. So let's look at what generates GHH and GNN. So 2 GHH, X1 XOR Y1. Okay, great, great. So this is gonna be oh, we can inspect. This is actually pretty small. So X01 XOR Y01 goes to GHH. And GNN. GNN is going to be the carry from the previous one, right? So GNN, what goes to GNN? Y00 and Y00. Right, yeah, that's going to be the carry. Okay, so I drew these in the wrong order. But basically there is, oh, and the zeros column is going to be different. So this and column, which is also going to be the zero, right? So there's an and, which is x00, and then y00 connected to there. And I'm expecting this to go to z00. Those also go to g and n because that serves as a carry. Well, hold on, this only has one output. Oh, yeah, so this is actually going, how am I going to draw this? Eh, g and n. Okay, and then what leads to z00? Z00. It is still the XOR. Right. So here we have z00. Um, am I going to do this entirely? I could do this entirely in here. I mean, okay, I can do some programmatic checking. All right. So z00 should be connected via an XOR to x00 and y00. What pointy? So that goes there. That goes there. Yada yada. Okay, let's check. So we can search for all of the XOR gates that combine x00 and y00. Um, and each of those should be, so except for the first one just goes directly there. The second one goes into another XOR, where it's XORed with the carry from the previous one. So it's XORed with the carry, and then it goes into another value that is ANDed together for the next carry. Wait, you XOR it with itself? No. Yeah, you XOR it with the carry, with the previous carry. Okay, so I'm gonna start giving things different names then. Um, um, I think we can do this like pretty manually with a copy paste kind of a process. And we're not gonna bother running anything until the end, really. So how do we find z00? So we do init gates z00, right? That XORs x00 and y00. And then we look for the AND of those two because that's going to be carry. So we'll call that carry 00, val c00 equals init gates dot, we'll do find. And it should be, I don't know what the name will be, but I do know that the gate um, should be an AND. So we'll iterate through this manually until we get past the ones bit. Um, so, and x00, y00, let's just assume, I think x is always going to be first. X01 and y01. Yeah, so the x is always going to be on the left, and we could normalize this so that the x always appears on the left when we're parsing it. To do normalize, I think the x will always appear first, so we don't have to worry about that. We're gonna do a collect. So we're gonna do a collect first case where we have an and x00 and y00. And then what do we do that? I guess C00 is that name. So the C00's name is this GNN. So that's the carry 00. And let's just do dot get there. Now the carry 00 GNN is carry 00. Okay. Now what should happen to the carry 00? It gets XORed with the output of the XOR X01 and Y01. I don't know what to call this. So this is gonna be like the add. So we add those two with the XOR. And then we XOR it with the carry to decide its ones bit to get Z01. Tendiku, thank you for the follow. Yeah, let's keep doing it. I think we can make good progress here, and maybe we'll end up doing some copy paste, but let's call this A01. A01 is going to be same deal here. Init gates collect first. Something that is connected to both I don't know, the XOR X01 and Y01. And GHH, great, that's what we were looking for. And before I go on, I want to look at the nature of the swaps. Are just like outputs swapped? 4 pairs of gates whose output wires have been swapped. Okay, so we don't need to worry about the inputs being wrong. If we search for a gate by using its inputs, that is reliable. Okay, so def, I know we want like a get gate function. Get gate. Gate. And this will just become a one-liner. And we'll let that error out. And we're going to have it use a modified gates. So val var modified gates, because we want to modify it at various steps to test things as we're going. Modified gates starts at init gates. You got it. Awesome. Great job. How did you do ranking wise? And I'm gonna guess that you did it by reverse engineering, but I'm not gonna ask. Oh, so I know we'll call this mod gates. Mod gates. So we search for that particular gate name and gate. If gate equals gate, sure. Name and G, we'll call it G. If G equals our gate. And then we'll do a get. We found a string. Oh yeah, we're returning a string. Yeah. We want the name of the gate. We're gonna rename this the name of what even is part two. Part two is fun. It's reverse engineering. Okay. So the main add of 0, 1 is called GHH. Great, and we can start using our new function here. So Z01, let's look at gate Z01, and it should be, well, actually we can find the add, we can find the XOR of these two, and I think it should be in the order. Let me see. So GHH XOR GNN gets Z01. Okay, so name of, so this needs to equal Z01, but it's going to be name of the gate XOR. GHH is our A01. So X XOR A01. A01 would see the carry from 00, C00. So this should be Z01. And then this should be, this will be what we call carry 01. So val 01 was that. Val carry 01 should be an add of those same two. And, sorry, QHQ. Great, so we keep doing this, and this essentially just becomes like a bunch of copy paste. We can change this to name of, and same here. This is just going to be name of. And yeah, I guess this is val Z00. Okay, so we can chunk these. So A01, Z01. Why am I calling it Z01? Yeah, because it ends up in the zero, Z. And then C01, right? And then now the A02, same kind of thing. So we do that, except A02 starts here. And Z01 is going to be the name of. Wait. This is A02. So Z02 should be the name of A02 and C02, right? Same kind of thing. Now that we're getting the idea here, I might turn this into a function. Wait a second. C02. No, it's carry 01. We carry 01 over. And there's no x02, y02. Is there really? Okay, so x02 and y02. So that has a value. But is there an XOR? Okay, so we already found a bug. So we can find that by inspecting the things that are around it. This doesn't exist. How do we? So let's look at Z02. Now Z02 equals negates Z02. And we'll use that to explore. So the gates on the left and the right are Z01 are the adder and the carry from the previous one. So we could do this val XOR, and we have A01. No. This is going to be A02 and C01. C01. I guess we're reassigning that value. It needs to be connected. Z02 needs to be connected to QHQ. Or maybe Z02 is connected to like the wrong output altogether. MSP and FWK. Say you took a hybrid approach with 3 parts, and one of them is definitely reverse engineering. Okay. And you got just a couple minutes before giving up. Yeah, I'm going to keep doing it like semi-manually here without the worksheet until I feel like I know what I want to automate. So the carry 01. We could look for things that's added to. I want to be able to like search things that have carry 01 on the right. So let's do that. And that'll help us find the next series of things. So init gates, I should be playing with mod gates. Mod gates.find, or we're going to do a collect first. And what this is a string to gate. So case name, and we are looking for an XOR gate that contains C01, the carry on the right. XOR whatever, and then C01. And we want the name of that gate. So P and H is going to be A01. But it should be. mm, Well, I mean, this goes both ways, right? So we can look at the XOR of, well, where else does A01 go? Actually, I think A01 is fine because it's just a straight XOR. Um, so that's the real A01. I don't think anything's wrong with that. Um, I think in addition to our, no, we're no longer running our part one code. We'll give these new names. So GHH is what we'll call A01, and GNN is what we'll call C00. Right. Um, yeah, which is also GNN. CO1, I'm pretty, so I should be confident that this is the correct name. Let's see, the output. So this is what's in place of the output of those two. Right, so A01, that's solid. We're going to use that as the name. And we're also further confident in it because Z01 uses that and that correctly. C01 could still be wrong. So the output is QHQ. QHQ might need to go somewhere else because the thing that should be C01 let's see, there's always going to be a carry on the right XORed with an A on the left. So let's say A02, which we don't know what that is yet. We don't know what an A02 might be. So we could work backwards from here. This Z02 is an XOR of MSP and FWK. This gives us nothing right now. Yeah, not sure how to resolve this conflict just yet. So this is an XOR of MSP and FWK. The one on the left should be A02, and the one on the right should be C01. Conflict. We'll call it the conflict. Okay, so A02, what about it? It's MSP, right? So this XOR MSP FWK. And we look what is ANDing X and Y, I suppose. Yeah, let's look at this. Oh, I think we couldn't find this, right? A02. There's nothing XORing those two. Okay, but is there something ANDing those two. GPN. Okay, so the thing that ANDs those two. Wait a second. No, nothing to ANDing those two. Is there anything ANDing x01 and y01? Oh, okay, I guess there was. Okay, so where does that AND need to be used? I'm missing a bit of the circuit here. So for 0, 0, and 0, 0, that became the carry. Okay, this QHQ. Um, Interesting that there's a direct AND of these two. And I guess that would be the carryover, wouldn't it? That would be the carryover. Let's look at our adder image. Mm, yeah, the AND is a carry. So something else was wrong earlier on. So this is not C01. So these two get ANDed together, and that is C01. Okay. So that G and N then is kind of fishy. Yeah. Okay. I clearly don't completely understand the structure yet. Um, so A01 is the XOR of those two. What is going on with name of and of X01 and Y01? X01 and Y01. Oops. Whoops. NCK, that should be the carry. Okay. Big man 24/7. Thank you for the raid. Welcome, all of you. Hey, Gruner. Gruner coder. Are you drinking Gruners as you code? So I assume all of you are doing Advent of Code. Day 24, part 2 is where I am right now. And I'm doing some kind of a worksheet assisted reverse engineering here. And I'm realizing that I found something fishy here, which is that this GNN is used in Z01 in my when I would have normally expected that in an adder, that would have been like this should be X01 and Y01. Right? Like this should be going straight to that bit. No, because it can't go straight to that bit. because it has to be XORed with. Okay, hold on. This is because this is a half adder. Okay, that's why we want the full adder. Full adder, because a full adder also takes the right. Half adder doesn't have a carry input. Okay, full adder is what we want. Okay. Oh, you just finished. Great. Squeezed in under 1,000. Nice. 2 hours for 1,000. Oh my god, it's already 2 a.m. Awesome, great job. I think I'll get there. I was just operating with a half adder instead of a full adder, so we'll give these things names. Um, right. So there is. Oh, right. See out. Okay, so the x01 and the y01 go XOR into this, which I'm calling A01. That itself gets XORed with this, which I guess I was calling C00, but that's not the right value for that. Yeah, because C00 is way down here. So we need to give them new names. I guess I could just call this A01, and this can be, so it takes a previous value, C in. This is the one that takes C in. Um, so these are XORed together and they're added together. And the added together, well, let's do this in the worksheet. You're not feeling well tonight? Oh, well, thanks for stopping by. I appreciate the raid. I hope this problem was treating you all right and that you're all ready for tomorrow. Okay. Yeah, so our part one, or our ones column here, we need to give things different names here. Um, so A01 is just going to be the name of XORing those two. And then we'll just call this E01, which is the name of ANDing those two, right? Let's put an adder diagram on the right. Full adder composed of two half adders. And let's see. Let's look at init gates Z01. So this isn't Z01. Init gates Z01. This is the XOR of, well, okay, so these two, wait, what gets XORed? The input, okay, the carry gets XORed, the carry gets ANDed, along with A01 and B01. Yeah. So in the case Z01, let's take a look at this. GHH and GNN. So GHH is actually our A01. What do we call this? We're going to call this So A, B, you could call these A, B, C, D. I want better names because I want this to be C. And this is, we'll call this O01. And O01 should be the same as Z01. So let's do val O01. It's going to be the name of A01, which is the XOR. Let's call this XY01 because we're XORing them together. No, we'll just keep calling it A. So this is going to be O. I don't know what this is going to be. Maybe O and P. So A and B, O and P, and then C out here. Okay, so O01 should be name of XOR A01 with C00. Name of great. And name of let's see, O01 should equal Z01. Okay. And yeah, we could keep checking by what things are wired together. So we have B01. Great. Now we have like a P01. Val P01 is going to be A01 ANDed. So it's going to be the name of and A01 and what? C00. Okay. And val C01 should be, oh, it's going to be an OR. Okay, it's going to be an OR of P01 and B01. Wait. Yeah. there is none. Am I getting that right? Maybe I have to swap order here. So P, which is this one down here, the AND gate, QHQ, and B, which is the AND. Oh, we don't have a B01 yet, do we? No, we do. But that apparently does not exist. So let's try swapping the order. B01 and C01. Oh, no. P01. Okay, that's the order we do it. Okay, so that's the next output. Okay, and I think we basically can copy paste this and do that for each. I'm only gonna copy paste it once, and then I'll go to code. But we basically increment everything. I know how do we do this. So these are now the twos that we're setting values of. Hold on. X01. I want to start not using strings here. No, we'll continue using strings. Okay, we modify all of these to 2. 2, C00 gets incremented to 1. And then 2, 2, 2, 2, 2, and 1. I suppose I could be doing that with like a find and replace. And this one seems to be missing. So this tells me perhaps there's a misnamed thing, or perhaps we just haven't updated these properly. Here we go, 2 and 2. There is no XOR of X02 and Y02. Oh, well, that's fishy. There should be an XOR of those two. And there should be an AND of those two, right? All of them, that should happen. Let's look at our input. X02, XOR. No. Okay, X can't be one of the swapped labels. It can't be one of the swapped wires. Right, it has an initial value. Okay, let's do X02 AND. No. X02. Oh, that's X02. X02 and Y02. Well, we've at least got the AND. And it wasn't one of the bits I identified as being incorrect. At least I was able to add its I don't know about the carry, but got the add part right. Um, interesting. X02 and X03 XOR. No, there's no XOR there either. There's just ANDs. Okay, so I think I'm misunderstanding the circuit then. Because this is an X, this is a Y. And they should be XORed as they are here. I don't know. Is there an OR of these two? Nope. There's no OR. There's no XOR. There's just an AND. Okay, well, let's work with that. You want to find something that has GPN on the left. So I'm going to copy this code here. I know G dot A equals GPN. We get that name. I think we want that name in that gate. So this is just going to be like a, I don't know, this will be a find. Okay, GMP ORs those two. Gonna turn this into filter, and then a for each print line. There's only one. So GPN, call this B02, right? That's an OR. It should be an AND. The thing that uses that on the left should be an and. Does anything use that on the right? G dot B equals B02. Okay, yeah, there's nothing. Okay, well, OR gates. OR gates are always here. They're always these out these carry gates, right? So that's telling me that this gate here is mislabeled, the gate that ANDs these two. So we need to change the name of that. Change name of B02. Well, actually, no, that's fine because that is supposed to be ANDed. That's supposed to be a part of the carry, so that's fine. So that's B02, and this here is in fact C02. So if you made this a dot head, this is going to be C02. And it's ORing a GPN with VBS, so we could search backwards from VBS and see what that's ANDing together. So this is C02, the carry 2. And let's see, init gates VBS is an AND. Okay, that should be an AND. And that will be ANDing what was it ANDing? It should be ANDing. This is P02. So we're just asserting that it is VBS. And then we can copy. What do we copy? Oh no, we're doing this in the opposite direction. So P02 is used in C02. Wait, that's in an AND. I don't think I'm following this correctly. Okay. Init gates VBS is an AND. And the AND there, I should draw my own version of this diagram that has my names in it. But we're calling this bottom right gate of the quad of the second half adder. We're calling that P. So that's P02. And it should add C01. Whoops. So C01. It should add that with A01 or A02, which that's the XOR of the X and Y02. CO1 is a double definition. So here's a CO1 conflict. Okay, so we have A02, and let's see the C01 conflict. I don't think that's a conflict actually. MSP and C01. Okay, so those are equal. Cool. So that does give us A02. And let's look at init gates A02. And that should give us what, that should give us an X01 and Y01. Right, that should be an XOR. Wait, there is an XOR. Why couldn't I find the XOR earlier? A02 is the name of XOR. Y02, X02. Oh, I see. The orders sometimes swap. So Y02, X02. Okay, so I should just normalize these. I'll normalize it so X is always on the left. But for now, we figured something out. Okay, all these places where I was. I can comment these out for now. Now I know I can just swap the order, right? Should have tried that earlier. So val A02 is this, but swapped. Okay, so we have the name of the gate. Let's draw ourselves a diagram just so we know our naming scheme. So let's say, you know, we have an X and we have a Y. They both go into an AND. And then, well, actually, they both go into an XOR. Let's put the XOR up top. Maybe we put the XOR on top because I want to put the C up here. So let's put the C up here. Let's look at the shape of the diagram. I might want to draw our diagram in a different shape than how they do it. I think I want to have it oriented in such a way that the C out goes down here. So I do want to keep it the same. I guess I'm just drawing my C up there. Yeah, I'm just drawing it in a different location. So it's less confusing of an orientation. So these both go into an XOR gate, which we're calling the A gate. I know, let's make it nicer picture than that. So we want space to draw the A inside. Yeah, nice little point there. So X and Y go there, and then our B gate is the AND. Yeah, okay. Like, sure, but how are we? I want to put their names on it, so I can't do the box, and we have to have it pretty drawing. Okay, so we have a gate here which we've been calling the O because it ends up going to the output, right? So we have an O gate, which is another XOR. And circuit diagrams. Yeah, we do label wires, but the wires are mislabeled, so I have to label the gates instead. Right? Like this is a gate that should have the A going out. So that's why I'm doing that. But here's a labeled wire for you. Here you have an X wire, a Y wire. Um, yeah, okay, you're right. You're right. So we have an and you know what? I'm committing to it. This is now a P. And this wire here is what we'll call Z. Um, and then what gets wired together here? So we have the A and the C comes into both of these. So A goes into here, and then C goes into both of these. And this one is C prime. No. That needs to have an OR. Right. Yeah, that gets ORed. That AND gate gets ORed with the other AND gate. Oh, wait, the other AND gate doesn't plug into it. The XOR goes into there. Right. So let's back up a little bit. How can we draw this nicely? I guess we draw it down here. Okay, so this also goes to the top of this, and this goes to the bottom of this. And then now these two go into our OR gate, which is our next C. I'd like better names for these, but okay. So we can work with that. Now we have our A02. We have our B02, which should be an AND of those two. Great. So we have our first XOR and AND. Now our second XOR and AND should be the A's with the carries. So maybe we swap these two. No. Is there none like that? The A with the carry. Oh, with the previous carry rather. So C01 with a 02, or vice versa. Okay, I'm gonna change my name of. I'm gonna add a swap method to the gate. Yeah, I'll add a swap method because I don't know, just to normalize. Because it's not just gonna be the X and the Y's that are swapped, so we're not gonna normalize here. You used U, V, and W? Okay. Oh. Um, I know, def swap, this match. Match, I want an exhaustive match. And how are we gonna do this? We're just gonna multi-cursor. take these gate names and B and an A. Okay. Great. So now I'm do name of if G equals gate or G equals gate dot swap, then we go to name. We get its name. Okay. Now we can copy paste a little bit easier because the order is not going to matter. Okay, to get O02, copy this. And it's just going to be A02 with C01. When I write this as a function, I'm just going to use like arrays and whatnot. So O01 should be Z01. Oh, like this 02 rather. Okay, that's good. And then we have P, which is only used in the calculation of C. Okay, we have two iterations. Let's just do a third because at this point we can. I just want to test my process. I'm gonna find and replace 02s with 03s. I don't think we need, some of these were nice. Yeah, I'm gonna go ahead and delete everything except our findings from earlier. So we know that 6 and 0 and 7 of the output gates might be wrong. This we don't really care about anymore. Okay, so we've copied pasted, replaced 02 with 03. Okay, and then now we replace the 01s with 02. 01 with 02. 1, 2, 3. I wish there was a key binding to make this the last replace like there is in Emacs, so it doesn't loop around. Oh, interesting. Did we renamed one that we shouldn't have? It should be C01. Did we rename a bunch of stuff that we shouldn't have? A02 and C02. But we do have an A02 and C02. Wasn't that working just a second ago? I didn't replace any of those, did I? So I guess I could replace this name of with output of. Then we would have labeled wires correctly. I did what? XOR and then for O02, A02 or C02. Should be C01 on the error line. Oh, right. Yes, the previous carry. There it is. Okay. Okay. Great. And this continues to work. And we can make this a function, find the first place where it fails, but I think I already sort of know where it is. So let's look at 6. We're going to replace 03 with 06. And then now we're going to replace 02 with 0, 5, which doesn't exist. Okay, okay, we're not going to do this. We're going to use functions. Yeah, you're right. I mean, I could totally just make this like a macro. I could I could write something that prints this code for me. uh, I totally could. I totally could just write something that prints all this code for me, and then we inspect it manually that way. Um, I'm tempted because what happens is when we run into an error with a function, I don't really know what to do when we have an error. I mean, a function I guess could help me if I had these as arrays that we are mutating. And at least like we index into it. Yeah, we're metaprogramming. This is a hacky macro. Okay, you know what? I think I will do that because we're working with worksheets here. In fact, I'll make a day 24 meta worksheet. Well, no, we'll just do it in here. So def, yeah, we're just gonna call it meta. And then we have an index int. And then all of these are gonna be inside of print lines. Triple quote, triple quote. And they'll all be interpolators. So all the 0 3s will be replaced by i's. So 0 3 we are replacing with $I. Okay, great. Now all the 0 2s we're replacing with $I minus 1. 0 2 $I minus 1. Okay, well, this is an approach. And this is just a unit function. Now, for I, yeah, for I from, what is it, from 4 until 45? No, 44. 44 is the last X input, right? Just take a look at that. X45 does not exist, but X44 does. Oh, I mean, I guess we do this until 45. Well, hold up. Yeah, until 44. And then I guess the C becomes the last Z45. So C44 becomes Z45. So for I from 4 to 44, we're going to do meta I. And we'll do a print line in here. Your code found the places with problems, and I worked out the wires by hand. Yeah. Yeah, I mean, this is certainly a better way to find the places with problems than what I was doing earlier, running the whole simulation on each column. Okay, so we're going to copy that worksheet output, and we're going to go to Scratch 5. And we've got code. It needs to be uncommented, but it's wait. Where is it? Here it is. Yep. Okay. So we can comment that out. We don't want it printing every time. And now we take this whole thing and we're just going to uncomment that block. Whoops. Okay, too far. Ha! Okay, let's give it a run. Oh, I think this is hilarious. Okay, C3. Oh, hold up. My code is wrong. Okay, we go back to commenting that. This needs to be an F interpolator. Yeah. Okay. So this is an F, and each of those dollar I's needs a %0D at the end of it. Where like this here. %02D. Oops. Okay, so we're gonna replace I. Oh no, we're gonna replace $I. $I with $I %02D. Yep, printf. Ever a classic. Okay, and then the I minus 1 gets replaced too, so I minus 1 gets replaced with I minus 1 %02D. Whoops. That too many times. Okay, now we're going to run this. Don't need this. You came up with 2 algorithmic ways to solve it and ended up using one of them. Nice. How does like all the way through, no inspection? Like it corrects the swap too. Now was your algorithm like precise about what needed to change? Did it know what needed to change, or did you like sort of try some swaps but in a limited search space? Um, okay, these are getting it autocorrects it. Oh, very nice. I'm impressed. But see, I want to go back to the Scala Discord and say, hey, I solved today's with metaprogramming. For those who don't know, Scala does have a very robust metaprogramming system, and you get cool points for being good at it. Okay, let's look for some faults here. Or some failures too. Look at that. So Z07 is false. You knew the structure of the code is going for and inspected which parts of the node tree didn't match what I expected. This is like C++. Oh, well, C++ metaprogramming is different. right? Like C++ meta programming is sort of more string based, and in Scala, it's type safe and it's very much kind of a tree based, right? So meta programming in Scala is kind of like a plugin into the API of the compiler itself. Um, it's very cool, and if you like the idea of meta programming, I recommend looking it up. Okay, so we have an issue here, and we can't find because this. So what is wrong here? See, I don't know how I would auto-fix it yet. I have to at least manually fix one thing. You still get cool points for doing it? You mean your coworkers don't get mad at you? Likely figure none of the X, Y, or Z variables should be swapped at all. Nope, that's not true. Some of the Z's are pointing at the wrong place. I know that for a fact. And I know that because there is like I don't know. Some of these arrows to Z have like OR gates and AND gates leading into them. Oh, there's one right there. See, there shouldn't be an AND gate leading there. There should be an XOR gate. Um, and it could also be that they're just pointing to the wrong output bit. So that's fun. C++ has concepts that make it more type safe. Yeah, I wouldn't know too much. I just know the rudimentary that's kind of very much string based at the start at least. You're not getting part two, as in you don't think you're going to solve it, or you just don't understand it. Okay, so the XOR of these two, um, that tells me that so the fact that this doesn't exist tells me that A08 or B08, one of these are mislabeled. So we can kind of reverse engineer it by looking at what, well, hold on. I guess we have to reverse engineer it all the way from the Z. So let's look at, oh, actually, no, there's a mistake all the way back here. So this ends up being false. So the name of this XOR of these two. So the XOR of these two exists, which makes me think that this name is just mislabeled. BGM should be Z07. Well, O is not used anywhere else. So let's do a modification here. So mod gates. Actually, let's look at mod gates at Z07. And what is it pointing to? And it's probably not going to be, wait, TGJ. No, hold up. Okay, it's pointing at an OR. So this OR is wrong. So this is mislabeled as Z07, and it's an OR, which means it's actually some C. Well, we'll call this a fake. I know, we'll call this a Z07 fake. Just so we can save it. And then once we figure out what that's supposed to have been, what does OR lead to? Whatever OR leads to, or whatever uses those two, I think we can assume that those are correct. So that is some random, what are the ORs? B gate and P gate. So some random P and B. And we'll figure those out eventually. Well, okay, actually, we can do this by finding the paired and. So the B gate and P gate, where else are those used? Well, the P gate, I guess, is not used elsewhere, but the B gate is used somewhere else in a few places. We can do knit gates filter 2.a equals njc. Actually, we don't know which gate is which yet. So let's just save the value of this Z07 fake. And we'll update. So mod gates Z07 is going to be this here. The XOR of that. So we'll do the update here. And later on, we'll figure out where BGM should go. Wait. BGM or BJM. Hold up. 007. No. This is wrong. Z07. 007. Right. So this XOR is labeled wrong. It's currently labeled as BJM. So let's look at what BJM is. Oh no, I mean BJM is currently that, right? Mod gates BJM should be labeled Z07. Name of those two is BJM. So how do we do this? This isn't the fake Z07. This is where Z07 is currently pointing. So it's so this is a fake 007. Or I don't know, which one do you call the fake? So that should be labeled as Z07, and this is where Z07 is actually being pointed. So we want to update mod gates. Z07 should equal this one, right? Yeah. And that should happen before this happens up here. And before that happens, we save the old value of Z07. And maybe we just do that as a swap. So now mod gates BJM, they are all swaps, right? So this is going to be mod gates So the old fake. Z07 fake. Right. Okay, so that's fixed. Now, now this should be equal when this runs again. And then we fixed another gate that will appear later on. Wait, mod gates. Update is not a member. Oh. Right. We don't want to make this a var. We'll make this val mod gates equals init gates that, I don't know, we'll make a mutable map from that. So collection.mutable.map.from init gates. Okay. Now we can perform that modification. And what is our answer? What do you get if you sort the names of the 8 wires involved? Oh, wait, you just need to know the names of the wires. You don't actually have to fix anything, do you? You might have to fix something to continue your search properly. Okay. And then now here, there is no issue, right? Did the issue disappear? Yeah. Okay. So we have a bunch of trues up until 13. Right. So fixing 6 also fixed whatever was going on in 7. Z13. Okay, so we're getting here HSW. So we have Z13 equals the name of, or no. I'm going to do this a little bit differently than I did it last time. So this is the Z13 like original gate that I was pointing at. And we'll do mod gates Z13. Yeah, you need to continue to fix the chain. Otherwise, exactly. It is all dependent. Okay, so what gate is this? So that's an AND gate. And what do we want to do? We want the name of that gate, I guess. No. We want the name of this gate. So O13 is HSW. So we need to swap Z13 with HSW. So mod gates Z13. No. HSW should be O13. No. It should be whatever the old value is. So the Z13 gate. And then we mod gates Z13 to have this gate here. Okay, I want to see how I did it in the previous one. I like that better. Wait, you work backwards from the end. So you work from the most significant digit first? Interesting. Okay. So modgate Z13 needs to be assigned the value of the wrong one. Whatever this name of that Name of A13C12. So I'm just going to insert into here. I'm going to do it this way. So mod gates Z13 needs to equal that. And now O13 should match Z13 properly, but you also need to swap the other one. So mod gates HSW equals that old Z13 gate. Okay. And then now we check that O13 equals Z13. Oh wait, not name of, not name of. Um, let's see, val Z13 actual. There's the name of that. I need better names for these. So Z13 gate is whatever Z13 is pointing at. So this is like the fake gate. And then this is the current label. This is the current name. Z13. This is the current label on it. And then now we need mod gates of that Z13 label. Needs to have the old value. So Z13 fake. And then Z13 itself needs to be assigned mod gates of the Z13 label. Okay. Let's put the label is used in two places. Yeah, I think I'm happy having this be my standard fix. Yeah, so the fake gate and the current label on it. So that fixes that. I think as we're going along, we should just add these. Val swapped labels. We're gonna make a list buffer. Mutable dot list buffer of string. Okay, so here was the first fix, and swap labels plus equals C07 and BJM. Okay, so mod gates. This is E13 bit. swap labels plus equals Z13 and the Z13 label. Okay. Now let's look for the next issue. Here we go. So Z18. Could a correct Z and incorrect Z be swapped? Yes, I think so. I mean, I don't know that that is the case, but I'll be looking for them. And I don't think it's impossible. Because you'd still have a puzzle to solve, even with them swapped. Oh, so I see. What did you do? It only works because of problem formulation. Okay. When you found a broken adder, you went to the next one and used the known input and output names to find the carry in name. Okay. I see. Well, I'll continue this way. All right, we have another case. So Z18. I'm just going to do the same thing here. Swap 13 for 18. Okay, so the Z18 fake, and then the Z18 label is 18 and 17. And we add Z18. Oh, this copy face feels dicey. Like, am I doing it right? I should make this a function. I should make this a function, actually. I think I'll make it a function right here because, well, actually, we only have one more swap to find. 4 pairs are swapped. Okay, so we can copy paste one more time. Okay, so this true now works, right? And then now we have an issue elsewhere. Come on, show me what's up. Okay, so we couldn't find an OR of these two, of B18 and P18, which tells me that P18 or B18 are labeled incorrectly. I mean, B18 seems fine. Well, let's see how it's used. Right, was B18 used elsewhere? Okay, so B18 could be the problem. P18 is the AND of A18 and C17. And since we were able to find that, I don't think P18 is, well, hold on. We were able to find both of B18 and P18. Okay, so this is a different kind of error than what we've been seeing so far. Okay, so we did find an XOR and an AND of those two. A18, where does it get used? O18 is the XOR of those two. Right. And we determined that it was mislabeled because we weren't getting a true. Okay, let's pull up my graph. So let's figure out what's going on here. Can we figure out what the C is? We could figure out what the C is by looking ahead. What the C out is. Because we're not able to find this, so we should figure out what goes into it. So we can comment this out for now and jump ahead. So A19 and B19. Are we able to find those? And of course, well, this line here won't compile. Oh, yeah. Let's make it error out instead of failing to compile. Valc 18 equals just triple question mark. Oh, no. It was a string triple question mark. We want to compile. Yes, I know. I'm on the actual. Yeah, it makes sense that we weren't able to get that, but what I want to do is search for anything that has A19 in it. So we do mod gates dot find. Let's do a filter. So case, there's a name and a gate, and either gate.a equals A19 or gate.b equals A19. Well, hold up. Yeah, equals the name A19. Okay, so let's take a look at those. And then its pair is a candidate for C18. Right, because this goes into, yeah, the A goes with the carry from the previous one. Oh, okay, so there are two. There's an XOR and there's an AND. Oh, hold up. I'll show the hover again. Show hover. Okay. So something that has A19 here shows up in an XOR. Great, that's the Z. And it shows up in an AND. And the AND is what we want because the AND will have wait, SCD is the A19. So RRQ is a C that we're looking for. RRQ. Hmm. Um, Great. So this is going to fail to work because should be RRQ. Right, that's what we found. Look at this hover. RRQ. So we swap RQ into whatever has it. So I don't know. Mod gates RQ. We're just gonna start calling these temps. So val temp T18 is the gate that's at that value. And now we can replace mod gates RQ with the current value of, well, hold on. RQ is a label that should be applied to that, right? So T18 is the wrong gate, and the wrong gate should go to whatever the current tag of this is. Yeah. This is the gate currently pointed to by RRQ. And we're not going to assign that yet. Eventually we're going to assign I know, mod gates RRQ equals T18. And before that, though, you've got to replace something else. What is it? We are so close. We are so close. Whatever is currently being pointed to, or I don't know, whatever is currently pointing to here, name of this needs to have whatever value is currently in RRQ. So mod gate's name of that, which is not RRQ, should be T18, that gate. Oh, and I guess mod gates RRQ should be this. Well, okay, great. So the name of this is currently something else. So it needs to be assigned to that. Okay. And then we're gonna add things to a list. So swap labels plus equals RRQ, and what else? Name of this. Okay, so that should do that. And we can remove this here. That seg, did you just finish? Today's is fun. I think I am right on the verge here. So this is my last swap. Oh, what happened here? None.get, because we already reassigned it. Wait, did we already reassign it? Name of B18, P18. Oh, we weren't finding this. Oh, we don't know what it's currently. Okay, that's the wrong thing to search it by. B18, P18. Wait a second. What was the issue? So the issue we were originally getting was that this fails because we can't find anything that's made up of those. We shouldn't have to change any of the input value names, right? So this is just an or of two things. Oh yeah, totally. Spoil me in part one. I want to rewrite my part one. I think you can make it really nice. Take your 2015 day 7 code and change like 5 lines. Oh, all right. Oh, does this not? Hold up, hold up. This references 2017, doesn't it? No. No, this references 2022. Okay, let me just comment this out again real quick and see what the error was. I think P18 is actually the mislabeled thing, right? Because we can't find this. We can't find this, but what we did find was that which gate? So we looked ahead. A19 gate.b equals A19. Yeah, we were looking for something that would tell us what this C is, or what's supposed to be the C. So we learned name of P18, P18. We learned what name that should be. So that name should be RRQ. Right. And the next step that's coming from the C. Hold on. So if this name here should be RRQ, it's not merely mislabeled. It's not merely mislabeled because it's just not finding it. So I mean, it might even be labeled correctly. It's just that B18 or P18 have the wrong name. Right. Okay. So we'll do this differently. Instead, we'll do mod gates RRQ and see what gate this is. And this should tell us what the correct B18 and P18 are. We might need to do more than that, but we have TGM, and SKF. So P18 is TGM. So this one should be SKF. O18 should be SKF. Interesting. No. Did SKF get swapped with that? RRQ. No, not O18. Sorry, P18. So this is TGM, and SKF. TGM is already found here as P18. And the B18 is incorrect. So B18, this should be SKF. SKF. That's currently labeled as, wait, it's labeled as Z18. Well, that's weird. Okay, so we should do the swap earlier up here. So SKF and Z18. So whatever this is, oh, right. Yeah, let's just do the swap sooner. I'll move this line down. And see what happens. So we still have one more swap to find. Okay. So B18, we wrote that should be SKF. Cool. Yeah, great. So we're no longer seeing errors here. Mod gates RQ is fine. Okay, so we just did the swap, but not early enough. Okay, let's find the next issue. Oh, look at here. Oh, nope, that's fine. True, 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 true. At some point, here we go. So we're not finding this gate, so the name of A26 or B25 is incorrect. Okay, so we need to correct those names. How do we figure out what those names are? Well, where, so that results in our A and B gates. So where are the A and B gates used, and which one can help us? No, okay, A gate, B gate. We're not finding this O. Oh, it relies on C25. C25 might be wrong. Yeah, so we can search for things that have an A26 in it. Where does that search code I had from earlier? This. Okay. Gate.A equals A26. Or gate.B equals A26. And then what should this tell me? The real name of C25. If C25 is a mislabeled one. Okay. FRT and NVR. NVR is the name of the A26. FRT. So C25 should be FRT. Right. And what is currently at FRT? So inputs, let's see, mod gates, FRT. Oh, wait. This worksheet evaluation is taking too long for me to be having. Actually, I shouldn't be running anything. Is part one still running? I know. Let's go back here. So FRT is QKF and WKR, and I don't know. Oh, wait. QKF shows up right here. Wait, this is an interesting swap. So C25 is currently labeled as QKF. And FRT is like the actual value, so this should be, oh. FRT's actual name. So this needs to be the OR gate here. But instead we're getting the AND gate, which is QKF and WKR. Do we have an AND? Did we just swap those two? Yeah, evaluation does seem really slow. And I'm not doing anything fancy though. right? Like this is all the part 1 stuff, and that's not, oh, whoops. Okay, this is still running. There we go. Okay, now it should be instant. Yeah. Okay, so C25 should be labeled FRT. So this OR gate should be labeled FRT. Currently it's labeled as QKF, which interestingly is in the end of this FRT. I think we just swap them around. Does QKF appear any earlier? I don't know. Let's do val T25 equals mod gates FRT. So that's our temp, and then we're going to do mod gates QKF, or no, we're just going to go ahead and replace FRT. FRT equals mod gates QKF. QKF, and then mod gates QKF equals T25. Okay, so we've got our swap, and let's check if things work. Oh, we have another issue down here. Okay, so maybe that was the wrong name to swap it with. But okay, at least this is FRT. O26, A26 and C25. What is C25? Right, we should be finding that. Okay, so we were looking for things that had A26 as a gate, right? Right, to find the carry, to find the previous carry. So pretty confident FRT is a previous carry, and NVR would be the A25. That should be NVR. Okay. But we're not finding NVR with FRT. Should I have been swapping with QKF? Not necessarily. So FRT was a previous value. Let's get the name of whatever this is. And this is a thing that should be swapped. Yeah, QKF. So this OR gate was being labeled as QKF. It needs to be labeled as FRT. So we just swap FRT and QKF, and that should be fine. And now we have 4 swaps. Swap labels plus equals QKF and FRT. And swap labels that to list and dot size. So that should be 8 labels. There should be nothing to fix after this, right? So I think I did that last fix wrong. 4 pairs in total. Yeah, size 8. Okay, so how did I do the swap incorrectly? This doesn't make sense to me because name of that is QKF beforehand, right? The name of that gate is QKF. The name of that gate should be FRT. So afterwards, when we do the name of again, it's FRT. I messed up there. Maybe A was issued and not. Maybe A was mislabeled. But this is XOR of Y. Well, this was already appearing there. So we are able to find an OR. So BQP specifically um, is a gate that has A26. And how many gates should have A26? There are two gates that should have A26 actually. Okay, let's undo this swapping bit. Because that feels like a mistake. Okay, so back to exploring this here. Okay, nothing changes. This A26 gate, XOR of these two, should appear in two places. The XOR should appear in another XOR and in an AND, but it's only appearing in an OR. So A26 is a wrong name. So that shouldn't be NVR. NVR is the wrong name. Okay. So name of that's currently NVR. What should it actually be? Let's do mod gates NVR. I don't know what's evaluating. There should be nothing running right now. Okay, and NVR is pointing to an XOR of X26 and Y26. Oh wait, right. No, but we don't want that. We think that A26 is mislabeled because, yeah, it should have a different name because FRT isn't the issue. What should the proper name of it be? Not NVR, but where does the proper label of that gate can only come from the X's and the Y's, right? The X's and Y's don't get swapped. All the A26s and B26s should be. I guess they could have, right, their output could be mislabeled, but then how do you figure out what they actually go to? I don't think any of the input wires are mislabeled. That's silly. Okay, yeah. Let's back off of that. So if A26 is a correct name, can it? I'm not convinced. Okay, so let's say we got XY, whatever. It's mislabeled, and we know it's mislabeled because it's being used. NVR is being used in an OR gate. So we need something that shows up in Z25, in this XOR gate for Z25 or Z26. So let's look at mod gates Z26. So that should be an XOR, one of which is this gate that NVR should be named. So XOR of QKF, that sounds familiar. QKF was a carry. Right. From earlier. Where is it? Yeah. The carry from 25 and WKR. So WKR is a correct name of this. So this 826 should be, WKR is currently labeled here. XOR the B gate. Wait, this XOR here should be the carry. And the A gate. That's the carry and the A gate. QKF and WKR. So WKR should be this. So I guess we just swap these two. Okay, okay. We have val, this we'll call it T26, tweet 26 equals mod gates, NVR. And we're just gonna keep this as a sign. So swap labels is gonna be NVR and WKR. And then now let's just copy the swapping code. So mod gates NVR and WKR. No. We replace NVR first. Replace NVR with WKR. And now we can replace WKR with T26, the former value of NVR. Okay, let's see how things progress. It should be good from here on out. And I still don't have any clue what's being evaluated. Add must be being called somewhere. Okay, but hey, look, that looks right. Okay. Oh, well, we're still doing this. We don't want to be printing all of that. But val, I'll put it up here. Val ands 2 equals swapped vet labels dot to list dot sorted and then what? Sorted and just make a string of commas. Make string commas. Solved with metaprogramming. We not actually get it yet. Okay, copy worksheet output. Okay, here's our answer. Here's our answer right at the 4-hour mark. There we go. No wrong answers hit today. Yeah. So that was fun. I should think of ways to do that faster. but hey, that worked. That worked. So that was certainly an approach. Um, just going through that manually. Is that really fast? And it would have taken me to. Well, I'm not. I'm still not sure how I would automate the swapping. I mean, okay, I know how to. Well, no, the error detection. Mm, I guess it's easier to detect the errors top down, going backwards. I would have to. I would have to think about that because I guess once you detect an error, you just do swap with whatever label it's pointing to. I didn't know why it took me so long to figure out how to swap the first two. Eric had no mercy. Yeah, yeah. Manually is a pretty good approach here. I mean, I had some help with my manual. Um, I did metaprogramming. Oh boy. Okay. How are we doing here? Day 24. Whoa, look at these deltas in here. Ugh. Oh, I placed above them by having, oh wow. So solved in 2 hours and then, interesting. Interesting that the fastest deltas here were both solved part one, like after 2 hour mark. Wow. Coded that so fast. I mean, I know I could code mine faster. I always spend too much time kind of modeling. I could just like go straight to evaluating, like straight from strings for one. I could just mess with the input. This, this I do want to rewrite this. So if you write this the correct way, you could end up doing this as like a for, you know, VA from the evaluation, and you don't have to keep passing that state along, right? So VB from another like eval. Um, so you could write something like that and then do a yield VA and then VB. And you can write code that looks like this if you do this using a state monad. And it will chain that through and it'll pass the state along for you so that you don't have to do this copying of state as you go. And you don't even have to think about a state modifications because that should be included in the eval. Right, this leads to value, but the value is wrapped in a state monad that captures the state as well. So that's what I would like to write. That's some functional programming mumbo jumbo. No, it's potentially really nice. So one day, like maybe that's something I could make a video on. Use some like ADVINA code problem. There like have been a handful of ADVINA code problems where you have a state like that. And you could show off how to use a state monad. Straightforward with 50 lines of code. Well, I would say mine is very straightforward, but it's 500 lines of code. 500? Are we serious? Um, uh, hey, well, this isn't Advent of Code Golf. Although I'll say my solutions usually end up pretty concise after I refactor them. So if you go through past years, that's what I have. Solid 200 and 300 over there. Nice. Um, but are those hundreds of lines all metaprogramming? Uh, so when I finish admin code this year, I think I want to stay around and stream. I want to do some sort of weekly stream. They aren't metaprogramming. It's actual code. Crazy. And a sheet of paper. Um, hey, you should share your solutions for this one. I'd like to see what you have. This was the straightforward one. Okay, let me pull that up. Um, but I was also going to say, after a couple of weeks break, I'm going to come back to streaming. I'm going to figure out a schedule. It's going to be like 1 or 2 days a week. So I'm thinking maybe like Wednesday at 5 and then some other night at midnight during my usual time. And when I figure out what that is, I'll put it in Discord. So if you're interested, you can find me that way. And we'll do something other than admin code. I mean, I might also go back through past years of admin code, and that'll be fun. I think I'll do that for a midnight stream. But I want to start some projects on here. So thank you. Yeah, I definitely want to stream more frequently. And I want to make some videos. So I have a few ideas for like a recap videos to make of admin code. One is like what I've been talking about, like my analysis of all my mistakes. I want to do some highlights on like problems that are really good for Scala, or like some Scala tools that can come in really handy here. What else? I have a few ideas. I do have a YouTube, and that's where they'll show up. I do also dual stream. I think the YouTube stream gets better quality, so it's worth checking out if the bitrate here is failing. The YouTube stream is on a lag. It's on a delay, so you don't get instant, but you do get better quality or better at handling any kind of lag on my end. It also doesn't have background music if that's your preference. Okay, let's take a look at some of these. Hmm. So this is the straightforward part 2. Oh, Michael PC Gamer. Hey there. You calling it a night on your stream? Okay, so we have a parse, swap and join wires. So we look for an XOR and we look for an AND, given, I guess, given the current number. So this finds the first half adder. Although we did find that some of these were mislabeled. And now if C0, the carry is not assigned yet, I guess, then we look for the AND. So we're searching backwards from the next carry. Okay, so if it's a Z, you do a swap. Wait, it seems like you're only swapping on things that have a Z, which in my case, one of them wasn't a Z. I'm not sure if this would work on mine. Am I misreading it? C1 and C1 starts with Z. Interesting, though. I might have to study that a bit more. Okay, what else do we have? I want to see some monsters. Um, Wait, someone else share code? Oh yes, I see Black Deep Space Bin. Okay. Auto. Okay, so this is for finding an adder. Oh, how to get the URL of this? Um, Copy address. Let's do this in Firefox. Okay. So adder. Oh, nice little diagram. So use UV and W and the carry out and carry in. And so you construct that by searching, and you search backwards. Um, oh, and this is C++. You use the cache hack once again. Wait, where would you use the cache here? And then, okay, away from building the half. And let's go to main. So, is this parsing code? Yeah. So parsing code, let's get into the XY0, add or build half. And then the last one. So from I equals 1, we go through. Oh, wait. Where do things get corrected? I guess during the build part? Guess full. Adder, guess full. X name, Y name, Z name. Oh, so you try to build the adder, and when that fails, you try to guess the full. Okay, guess full here. Um, Find if. Okay, let's get to the meat of this function. Okay, so you're just like traversing the graph and checking all of those. And if you find it, you do the swap. Okay, great. Okay, I get the general approach. It doesn't build half it. Oh, build half fails and prints an error, and then use guess full. Yep, exactly. And then you looked at the address build half said had problems. Okay, cool. Cool. I like it. It makes sense. I think that might be like what I what I would try. That'd be my first approach to like an intuitive way to fix as I go. Um, I still don't quite get that short one that was sent. Cool. A couple more hours you could automate fixing that. uh, who else? Hellhound, are you still here? I'm curious about your code, but you don't have to share. I think we should wrap it up and call it a night. And I think we'll do that by jumping to Snowstream again. How are they doing? 20, 21, maybe 22. Maybe 22, but you have 21 in this day. Is 21? Oh, yep. 21's the keypad one. So it's optimistic to get to 22 if 21 is on your docket. You feel like all the swaps were within the same adder, even though the problem didn't say they had to be. Yeah, within the same. Of course. No, good point. That would make it significantly harder. That's also partially why I didn't want to draw a graph, because I thought it would confuse the graphing software and just make it a jumbled mess. But right, good point. That's something to notice if you're solving this, because a more general solution would be harder. What does what mean? Okay, raid snow x cone within the same adder. Oh, right. So there's a graph of all the gates, and the adder is a component that handles just one column of the, like one bit result. Um, yeah, right. Like same column if you're just adding a binary number, long style. So the adder handles a column. Yeah, I think it's worth looking up how a binary adder works to solve this problem. All right, but thanks for everyone for stopping by, and I appreciate that y'all want to see me stream outside of admin code. So we'll make that happen this year, but probably a 2-week break before I figure things out. All right, well, good luck finishing that. And we'll see you all for the finale tomorrow.